So here's lesson 4-7, no, 4-6, on pages 168 to 171. I'm really trying to get better at these videos and it's just not working. But anyway, on page 168 at the bottom, you have example 1, very straightforward, finding the square roots of perfect squares. So 1a is 7, and remember that 7 times 7 is 49, but also negative 7 times negative 7 is also 49. Normally, if the problem doesn't have if the problem doesn't have the plus and minus in front of it, you're just going to usually just put the 7 without that plus and minus. So not too worried about that, but just so you know. For 1b, the negative sign is outside, so we're just going to take the opposite of whatever that answer is. So the opposite of the square root of 16 is negative 4. For letter 1c, because the plus or minus sign is included in front of the 100, we're going to put a plus and minus in front of the 10. And then notice on 1d, the square root of a negative number has no real solutions, but it doesn't say anything about imaginary solutions. So those are pretty straightforward on example 1. So my one sheet for chapter 4 is starting to fill up for lesson 4-6. I just added a little bit there underneath my scientific notation, the radical sign, and then I outlined it with the perfect squares up until 17 squared. And then I made a little note right here saying the principal square root is the positive square root. So normally when we find the square root of a number, we're just finding the principal square root, which is the positive number, but also realizing that both positive 5 squared and negative 5 squared result in 25. So just, again, encouraging you to take notes. It doesn't have to be in any sort of fashion. It can be just strict notes, but keeping all the main ideas on one sheet of paper for the chapter so that we can look back and review it. So for example 2 on page 169, we're looking at a different strategy for finding the square root. So in the first example, we were utilizing our memorization skills to just know those perfect squares. For example 2, we're going to be doing some estimating and then using a calculator to check. So for 2a, the square root of 60 is not a perfect square, but it does fall somewhere in between the square root of 49, which is 7, and the square root of 64, which is 8. Because 60 is closer to 64, we're just going to estimate that answer to be 8. Okay, and then we'll check with the calculator. Let's see here, the square root of 60 on my calculator. Every calculator is a little bit different on how you type things in. I'm using my iPhone right here, and on the calculator on my iPhone, can you see that? No, I think you can. I'm going to type in the number 60. I have to hold it horizontally, though, to get the feature there. 60, and then I use a little button on there. It actually looks like this. I think that was mentioned in the Edpuzzle video. That little 2 is not usually put there, but that's the square root of the number. So I'm going to tap on that button, and I get 7.749. So we estimated at 8, and if we did round to the nearest whole number, it would be 8. On example 2b, the square root of 23, the opposite of that, falls somewhere in between the perfect squares of 16 and 25. 23 is a little bit closer to 25, so I'm going to go ahead and estimate that as a negative 5. If you look at 2c, 2c is the square root of 14, and the square root of 14 falls somewhere in between the square root of 9 and 16, but it's a little bit closer to the square root of 16, so we'll go with the answer of 4. And then 2d, 2d is the square root of 79, but the opposite of that. So the square root of 79 falls somewhere in between 64 and 81, but have a little bit closer to 81. So The opposite of the square root of 79 is going to be close to negative 9. Again, not too bad. We're utilizing our perfect squares to use this strategy of estimating. Of course, the calculator will give us the decimal format of the square roots. So next up is example 3. For example 3, we're just using a formula that has an absolute value, not an absolute value, a square root in it, and it's just like what we've been doing as far as substituting in values for the variables and evaluating. So for 3a, it says that the lighthouse is approximately 55 feet tall. So on my calculator, I'm going to take 55 and then hit the square root sign, and then I'm going to multiply it by 1.22, and I get 9.0477, la la la, and it says to round to the nearest tenth of a mile, so 9.04 rounds to 9.0 miles. So for these types of problems, you definitely want to use a calculator because you can do the square root of 55 by hand, but it's kind of a tedious process in my mind. So using a calculator in this case is definitely a valid strategy. So on 3a, the answer is 9.0 miles. For 3b, it says that the Washington Monument is 500 feet tall. So I'm going to find the square root of 500. Again, on my calculator, I type in 500, then the square root key. But on some calculators, you hit the square root key first. I think there's a graphing calculator that I have where I hit the square root key first, then I type in the number. At any rate, once I found the square root of 500, I'm going to multiply that by 1.22, and I get 27.28. And again, it says to round to the nearest tenth, so that 8 will round it up to 27.3 miles. So far we've talked about memorizing perfect squares, and we can use that strategy to help us estimate non-perfect squares. And then, of course, the calculator is a valid strategy when we're also working with square roots. Next, we're going to look at cube roots. Last but not least, we're talking about our perfect cubes. And so if you remember a couple of weeks ago, we had a timed video that had you coming up with your perfect squares and your perfect cubes pretty quickly, just like your basic facts. So you might want to, on your one sheet, list the perfect cubes. I went up to 13 cubed. And if you can memorize those, it's just going to make things a lot quicker for you when you're doing computations. So for examples 4 and 5, we're just talking about perfect cubes. The first two up there are perfect cubes. The cube root of 64 is 4. And the cubed root of 1,331, notice it's a negative, and we do have a negative underneath the radical sign because a negative times a negative times a negative is a negative. So the square root of negative 1,331 is 11. You see it down there in the corner? 11 cubed is 1331. For the next two examples right here, those are not perfect cubes, so we're going to go ahead and estimate them just like we did the perfect squares. 72 is somewhere in here, right between 4 and 5, so you can estimate that as 4 or 5. No, closer to 4. And then 2024, the square root of negative 2024, if you look there, it's close to 13. And since it's a negative 2024, it will be negative 13. So hopefully that's enough information to get you started on 4-6. Good luck.